So this video gives you an overview of the new capabilities on the BlueSky Statistics 10 Beta 2. So I'm going to start walking through the new features in Beta 2, starting from the left of the top menu, moving towards the right. So here you have the triple bars, and let's go ahead and open up a CSV file. And as soon as you open up a CSV file, you will see that we give you the options to specify whether the first row contains headers, whether the field separators comma, and to specify an optional decimal character as well. So let's go ahead, and you see the CSV file will open up correctly. The next thing you're going to see is you have the ability now to load data sets from R packages. By default, we show you the data sets across all the R packages that we provide with BlueSky Statistics. If you know the name of the package, you can type it in, or you could just look it up by scrolling. I'm going to type in MT, and as soon as I type in MT, I get the empty cars data set selected, which was what I wanted. I'm going to go ahead and click the execute button, and you will see the empty car data sets opens. Let's go back to the dialog, and now let's filter by data sets in a certain package. Let's say I select Arsenal and I have the mock study data set. It only contains one data set here, which I can open up as well. So moving to the right, I have the datasets tab, and we've made several improvements to Reshape. We've got a separate video to discuss those improvements that we've made to Reshape wider and Reshape longer. Moving towards the right, let's take a look at the new compute dialogues. The compute dialogues give you a range of popularly used arithmetic, logical, math, string functions that you can access at your fingertips. Let's do something simple. Let's create a new variable test1, and we'll just sum up 3 variables here. So on each of these, if you mouse over each of these controls, we give you help and we tell you what to do. In this case, it says click on the plus symbol, which I've done, and then move the variables you want to separate with a plus. So I'm going to move these variables now, and you will see they are separated by plus. I go ahead and execute the syntax, and I move to the right, and I see the new variable that was created. I will bring up this dialog from history again, and now let's say if I don't want to move, if I want to concatenate 3 variables, let me select the 3 variables I want to concatenate. Let me move to string 2. Here I'm going to select concatenate, tells you to click concatenate and then move the variable. So I've got concatenate clicked, you see the blue color, and then I am going to move these. Obviously, I want to delete my old syntax, and here you've got the R syntax for concatenation. I specify an optional separator of underscore. I will rename my dataset. Remember, I brought that dialog up from history to test2. And I will go ahead and execute it. And if I scroll to the right, you should see the new variable was created. I'll go back to compute and bring up that same compute dialog again, this time brand new. I didn't bring it up from the history. And let me type in a new variable test3. In this case, what I want to do is generate a random variable by sampling from hospa. Again, I click sample and I move the variables that I want to sample. In this case, I will select hospa, and it'll automatically sample from hospa, and the number of items or the number of rows I'm going to sample is equivalent to the rows of my data set, and I say with replacement set to true. I go ahead and run that, and you see the new variable has been created by sampling from the hospa variable that I already had. Let me go ahead and do a conditional compute now. It's nothing but going ahead and applying conditional logic to my compute. So I want to create a new variable called test4. I'm going to make a small little mistake here, which I'm sure many of you will do. Let me put my condition. Clearly, I specify my condition here. So I say hospa is greater than 150. And then I'm going to say when the condition is true. So when hospa is greater than 150, I want to store high. And when hospa is not greater than 150, I want to store low. And let me go and run it. As I said, there's an error here. Let's go ahead and read the error. And basically, it's saying that the object high is not found. All right, and the reason is if you want to store values high is a string. In this case, I will put it in double quotes and a string will be stored. So there was no object called high or low before, and hence it threw an error. If I make high a string, I will see that this should work as I expect. And if I scroll to the right, I see my new variable created correctly. With that, I'm going to move on to the analysis tab now. And in the analysis, we have made improvements. You've got effect sizes with the t-tests and the multi-way ANOVA. Let's go ahead and select the variables for one sample t-test. I've got my effect sizes here. We've got Cohen's D. You can correct the bias for Cohen's D. You've got Hedges B, and you have the option to correct the bias for Hedges G. In all the other t-tests and multi-way ANOVA, we also have a glasses delta. Glasses delta is not valid for one sample t-test. And I went ahead and executed it, and here you see the results of the effect sizes. So as I said, you will have these effect sizes supported for all the t-tests and the multi-way ANOVA. Let's move on to the graphics. Two important improvements with the graphics. Before I jump into the graphics, let me go ahead and make cylinder a factor variable and make AM a factor variable and make gear a factor variable as well. And with that, let me go into the box plot. With the box plots, or rather all the graphics that we generate with ggplot, we've added support for faceting. So let's see that in action. Let me create a box plot of sale, or rather miles per gallon MPG versus the number of cylinders. On the x-axis, let me fill it by gear. And let me go ahead and facet it by whether it is automated or manual. So I can facet by row, I can facet by column, I can also wrap, and I can have a scale as well. By default, the scale is set to null. Okay, so with that, let me go ahead and run it. Now, all the graphics that use ggplot will support faceting, and here you see the facet for automatic variables and the facet, the graph getting recreated for manual variables. With that, the other thing I wanted to show you is associated with all the graphs that use ggplot, we have themes. And here I can go ahead and change my theme. The default theme is Theme Classic. Let me change it to Theme Black and White. You must apply the change, okay? And let me bring up the dialog from the history and let me rerun the dialog. And here you will see that the new theme has been applied to the graph that was generated. One thing I want you to note is that when you bring the dialogues from the history, we do not save the facets. Okay, so that's something that we're working on, but be aware that you will have to reselect the facet. Only these facet controls are what we don't save in the history. We will address that in an upcoming release, but I just want you to be aware of, and now you've got the graph exactly like it was in the beginning. The next thing I wanted to show you, which has also been highly requested, is that we've now got the ability to show you the equation in the regression. So if I run a simple regression here, it's not just the regression, but also in the logistic regression, we show you the theoretical equation as well as the equation with the coefficients populated. You can do that for a logistic as well as the mixed models as well. I'll show you this quickly with the logistic. And here I have my dependent variables, or my independent variables rather, and I go ahead and I create the model, and you see I have the theoretical equation and the equation with the parameters with the coefficients substituted. Now let's move on and talk about model evaluations. So under model evaluation, we have added support for scoring, and the scoring is available here. Under predict, you select model scoring, and as soon as you do that, you have the ability to specify a model here. We show you all the models available. By default, we showed you linear model, and this is very important. So under diagnostic tests, as soon as you have a model selected, we compare whether the variables specified by the model are available with the data set you're scoring. So the data set you're scoring is the active data set selected by default. Okay, so when you click this model scoring, we implicitly assume that you are attempting to score the active data set, and here we're showing you an error. And basically what we're saying is the variables that the linear model was built with are not available in this data set that you're attempting to score with this linear model. So you can click it and we will show you that you need to specify the column name prefix to store predicted probabilities and predictions where applicable. But typically you wouldn't click it. You'll rectify this problem, but I'm just going to go ahead and execute it to show you the error. So you clearly get a message saying the predictor variables that the model requires for scoring are not available in the data set. Let's bring up that dialog again. And now let's choose the right model. As soon as you choose a model that can be used to score the existing data sets, that is the variables that are needed for scoring are available in the current data set, you get the success here. I'm going to specify a column name prefix. Here you can have the confidence intervals. You can select a confidence confusion matrix, and as well as show an ROC table where applicable. You have all these options. These options were available with our C# version, so we've made them available here as well. And here you will see that the data set will get scored appropriately. The confusion matrix will be created, as well as the ROC table will be displayed. So here you see we've scored the data set, and here is the confusion matrix. You've got the ROC table, and you've got the ROC curve with the sensitivity and specificity plots as well. So let me go ahead and bring up or switch to the empty cars data set and bring up scoring again. And in this case, the model is the correct model. Again, let me show you. If I choose an incorrect model, I will see error here, but I'll choose the correct model. I will specify a column to store my predicted values for a linear model, the confidence intervals, and or rather the confusion matrix and the ROC table won't apply, but I can store the confidence intervals. I will go ahead and run that, and you will see that the appropriate predictions are created, as well as the lower and upper bounds of the confidence interval. The other thing that we've done is we've given you the ability to both compare and to summarize models. So you'll see summarize and models, and here you can select the models that are created and we will summarize them. And we'd use the same capability to compare two models as well. Okay, so you can try the compare n models on the right. The other thing that we've done, and in the documentation, we call this the triple bar and this the triple dot. So under the triple dot, we've got under settings, if you look under output tables, you have the ability to set the theme, the table font, and the font size. You also have the ability to run some diagnostics on the package details here. You can select a package and we will give you information about the package. You can also get details on all the installed packages that we have, so you know the exact version. Other new features include we ship R41. We've got a much improved code editor. Take a look at the video for the new code editor. We've got a video for reshaping and restructure data. We've got improvements there as well. You've got the ability to generate latex for output tables, as well as stability and overall several bug fixes. With that, we'd like to thank you for attending, and don't hesitate to reach out to us with any questions.